So let's begin. So in the previous class we discussed about what? What was the discussion in the previous class? Integrating factor. Okay. So you all clear about integrating factor? Right? So should we move to the next one? Okay. Okay, so let's begin something new today. That is linear ODEs. Linear ODE. So what exactly? Let's first understand what is this linear ODE, and then we can further analyze it. Okay. So first thing is we mentioned that is a ODE means it is a differential equation. It's a kind of special type of differential equation. So what exactly it is? Okay. A differential equation of the form that is y dash plus px y is equal to rx is called linear differential equation. So important that this is a linear differential equation. Any equation that is in this particular form, y dash plus pxy plus rx, then we call it's a linear ODE. Okay? If any ODE that is not in this form, we call what? The opposite one, non-linear. Okay? That means I must mention here, if the ODE is not in this form, then non-linear. Okay. Now in this ODE, now we further categorize this linear ODE. So in this linear ODE, if Rx is equal to 0, okay, if Rx is equal to 0, then it is called homogeneous linear ODE. Okay, first we differentiate linear ODE to linear and non-linear. ODE to linear ODE, non-linear ODE. Now our focus is only linear ODE. Now linear OD, in the linear OD, if the Rx is equal to 0, that means if you see this one, if the value of this one is 0, then the OD is called homogeneous linear OD. That means I can write y dash plus px y is equal to 0. So this one, this form is called homogeneous linear OD. Okay? So solving this kind of OD is very easy. Okay? How we can solve this OD? Any suggestion? Best way is possibly a separable method. If there is a possibility to separate x and y, we can apply that one. If not, then alternatives are there. So, to solve, what we can do? We can write dy by dx is equal to minus pxy. Okay? Then we can just apply dy by y is equal to minus px dx. Then we apply integration. That will give us ln y is equal to minus px dx plus c. Then we can say the y is c e to the power minus integration px dx. So most probably we can get a result something like this. It's the general way we can solve it, right? Now come to the second part. I believe all of you understand what is the homogeneous one. And it is very trivial, so we should not waste our time in the homogeneous one. Right? Okay. So let's move to the second part, because we discussed homogeneous, that means where the Rx is equal to 0, but complexity arises when the Rx is not 0. Okay? So, what is that? In the linear ODE, if Rx is not is equal to 0, okay, then the ODE, is called non-homogeneous linear ODE. Non-homogeneous linear ODE. That means which one? This one, y dash plus pxy is equal to Rx, and Rx is not is equal to 0. This one. In this, specifically with this condition, it is non-homogeneous linear ODE. Right? Okay. Let's analyze this one a little more detail so that we can figure it out how we can solve it. Okay. So this is a non-homogeneous linear ODE. Okay. Now our focus is this non-homogeneous linear ODE. Okay. Now this ODE has two parts. One part is this left hand side part and the right hand side part is Rx. Okay. So this left hand side of the equation can be recast into the form of exact derivative of a product by multiplying a function mu x. Yeah, first you write down, then I will explain what exactly we wrote. Little bit tricky, but it's not that difficult. So I wrote something here, mu x. Mu x something we discussed in the previous class. What was that? Integrating factor. Okay, it is the same one. So this mu x is nothing but integrating factor. Okay, so what exactly I wrote here, if I will write, I wrote the left hand side of the equation. Which one? Y dash plus px y. Left hand side of the equation can be recast into the form of exact derivative of a product by multiplying a function. What does it mean? That means if I will take mu x is the function and multiply with y, okay, then I will find out the derivative of this one. Okay, so if I will do this one, I will get what is mu dy by dx plus, this is derivative product rule we are applying. Okay, mu dy by dx plus d mu by dx y. Okay, if I will take the derivative of this one, this integrating factors derivative, I will get this one, right? So what we wrote here is, it is saying, so this part is equal to, what is the left hand side? That is y dash plus px y. Okay, pxy, what it is saying, that if we multiply mu here and mu here, they are equal. If we multiply this function with this, if you multiply the function mu with the left hand side of the equation, what is the left hand side of the equation? The left hand side of the equation is this one, y dash plus pxy. This is y dash plus pxy. What we do, we multiply this integrating factor mu here. Okay? It is saying that this one, when we multiply this one with this, okay, when we multiply this, that what we are getting is equal to when we take the derivative by multiplying the same function with y. Okay? That means what we got here. That means I can rewrite this is mu dy by dx plus d mu by dx y is equal to mu dy by dx plus mu px y. Okay? Now if you notice, this one and this one is same. That means we can just cut them. They are equal. Okay. For the timing, just ignore them. That means now these two must have to be equal. By that definition, that means d mu by dx is equal to mu px so this one must be equal because there is a y, both sides we can ignore them or cut them. Okay? Now when you got this one, what we need to do? We just apply the separable method. Bring all mu one side, all x to the other side. That means this is d mu by mu is equal to px dx. Okay? Now if we integrate both sides, we got ln u is equal to integration px dx plus c. That means we can further write this mu is nothing but c e to the power integration px dx. So the function that need to be multiplied with this one, with this function is mu. So we got how to calculate that one. That means it is a way we can find out what exactly that integrating factor. Just like in the previous chapter, we applied different method to find out the integrating factor. Now here we apply this method to find out what is that mu, what is that integrating factor. Now we have the integrating factor. Now important is that important point is that with this integrating factor, previously all the integrating factors are coming, there was no constant. If you look into in the previous class, all the integrating factor we have checked different way, we calculated, there was no constant. But today we have a constant c. Okay? So what we need to do? So I will just put few notes here so that you can understand this one. Even though there are infinite choices of mu, all produce the same desired result. So hence we can simplify the equation and choose C is equal to 1. Because whatever the C value you will get the same result. Because constant will not affect anything in the result. So that is why it is better to stay with the simplest one, that will, what was that? Something like multiplicative identity, which will not affect the result here. So if you take C is equal to 1, then our desired mu x is nothing but e to the power integration of px dx. Okay? Once we have this one, once we got the mu, what we need to do? We need to apply it for the solution. How? The solution to this problem is mu y. I'm talking about the same OD, linear non-homogeneous OD. The solution to that mu Rx dx plus C. Because initially what was the problem? I will write for you. The initial OD was y dash plus px y is equal to Rx. This was the original OD. Now what we do? We multiply here the integrating factor, that is e to the power px dx, e to the power px dx e to the power px dx. Right? Okay? Yes? But what exactly we studied in the previously, that this is nothing but this. When you multiply here the mu, that means here we are multiplying the mu in both sides of the equation. This one is nothing but d by dx e to the power px dx into y. Is equal to e to the power px dx into rx. Are you following me? If you have any confusion, you can ask me. Why I write this one? Because we have the integrating factor we found. What we did, that we just multiply the integrating factor both sides of the equation. And then in the beginning we discussed this one is nothing but when you multiply the integrating factor with this and its derivative. That is what? Right? So what is this one? This is the derivative of the integrating factor and y, multiplication. When you multiply, and right side we have the this integrating factor and rx. Right? Are you getting me? Now what we can do, we integrate both sides. By integrating both sides. That means we integrate d by dx e to the power px dx into y is equal to e to the power px dx into rx. This is integration plus c, this is integration. We integrate both sides. What we will get? We will get e to the power px dx into y is equal to e to the power integration e to the power px dx into rx plus c. Right? What exactly this is? This is what we wrote the solution. That means mu y is nothing but integration mu rx plus c. This is what the solution we wrote few steps before. Take your time, observe it, understand it clearly, then we will move forward. If you have any question, you can ask me. Okay, clear? That means if there is a ODE which is a linear ODE and it is non-homogeneous, the method is same. We have to first find out the integrating factor. Okay, and how to find the integrating factor? This is the way I just told you. Okay, what is that means? If the ODE is this one, insert what exactly we studied. The things I explain you to make you understand. That means insert, if there is a ODE y dash plus pxy is equal to rx, where this rx is not 0. Rx is equal to 0. If this is the ODE is given, first thing we need to find out the integrating factor. We need to find the integrating factor mu x. How to find out the mu x? It is e to the power integration px dx. Okay? And then once you got this integrating factor, your solution is mu y is equal to mu into rx plus c integration. This is your solution. Insert, that's just 2 lines. Okay? So to understand why this mu, how this mu, that is why we study so many things. Okay? Clear about this one? Okay? Should we move to solve some problems? No? Why no? You don't want to solve problem? Maybe 1 or 2 problem that you can understand more clearly how the problem comes and how you can solve it. Okay? You don't want to study, you want to go? Why are you saying no? No problem. You are saying no problem. Okay. So you should say no problem. If you say like this, I feel like you don't want to solve problem. Okay. So let's take one example here. A simple one. Okay. Y dash minus y is equal to e to the power 2x. Okay, so this is your ODE. First thing you can check, is this ODE is in linear ODE form or not? First thing, is it in linear ODE form or not? Second thing, is it homogeneous or non-homogeneous? Okay, then you can try to compare the coefficients, variables, which one is what, then you can apply it. Simple. That means this is in that form where you can say what is your P and what is your R. What is your P here? Minus 1. What is your R? E to the power 2x. Okay? So then calculate the mu, integrating factor. What is the mu? E to the power px dx. Integration px dx, that means minus 1 dx, which is e to the power minus x. Right? So if this is mu, then what is your solution? You just apply it. Mu y is equal to mu rx dx plus c. What is that? E to the power minus x into y is equal to e to the power minus x into e to the power 2x dx plus c. That implies e to the power minus x into y is equal to, how much is this one? E to the power x plus c. You can take the y e to the power x to the other side, that means y is equal to e to the power 2x plus c e to the power x, something this like this. That's your answer. Okay. Let's try one more. Maybe simple one, but a little bit tricky. Y dash plus 4y also. Y dash is equal to 4y plus x. Yeah, can you solve this one? First you have to write it in the form y dash minus 4y is equal to x. Then you have to specify what is your b, that is minus 4, and your r is x. So it is a linear non-homogeneous ODE. Right. So then calculate your mu. Mu is e to the power minus 4 dx, that is e to the power minus 4x. Then your solution, e to the power minus 4x, here is the solution, into y is equal to x into e to the power minus 4x dx plus c. Yes. How to solve this one? Can you remember how to solve this one? Especially I am talking about this integration. Can you remember? Okay, let me give you the hint. Integration of fg dash is equal to fg minus integration f dash g. Remember this one? Yeah, you just need to apply that one. That means here you can put, which one is your f? You can put your f is x and g dash is e to the power minus 4x. If g dash is e to the power minus 4x, then your g will be how much? E to the power minus 4x by minus 4. Right? So I am putting this one aside. I am just using this value. So let me use this value. That implies, if I write this one, it will be fg, that means x into e to the power minus 4x by minus 4 minus f dash g integration. F dash means 1, f dash g the same, e to the power minus 4x by minus 4 dx plus c. Yeah, so just apply it and solve. This is x into e to the power minus 4x by minus 4, and what will be this one? Minus e to the power minus 4x by minus minus plus 16 plus c. Yeah, all okay? If I am making any mistake, please notify me. So in the left hand side we have how much? The same, e to the power minus 4x into y. That means my solution will be y is equal to minus x by 4 minus 16 plus c e to the power 4x. And just multiply the e to the power minus 4x to the other side. I mean, divide, take this one to the other side. Clear? Very good. So try to solve more problems. Okay, go through it. And next week What was that? Thursday. Next week, Thursday, we will have a quiz. Okay? So detail about the quiz I will announce in the next class on Monday. Okay? Whatever we have studied, question could be come from anywhere. Okay? So I will provide you the update about the quiz, but just announcing the date next Thursday. We will have the quiz. Okay? Yeah. Thank you very much, guys. See you next week. Not test, quiz. Yeah.